Hey, boys and girls, Mr. Fleming here. Happy Monday to you. So, for today, let's go ahead and begin our Math Act Lab. If we have not done so already, for a good 5 minutes or so, go ahead and pause this video to accomplish that Math Act Lab time real quick. All right, so now that we are finished with Math Lab, we are going to need some materials today for our lesson. But before we get to that, let's go ahead and start our mental math really quickly. So for our mental math today, I'm going to write out a problem up here. Let's go ahead and do 2 1/2 times 1/3. Go ahead and on your slates, go ahead and let's work out that problem really quickly. And let's pause this video right now. All right, so go ahead and check in with your partner. Let's see what you got there. I got first eye, then I, last eye. This proves my answer is. And let's go ahead and pause that video to talk. All right, so now let's go ahead and take a look and see what we got. So I have some writing here, but so bear with me here. So we should have 2 times 2 is 4 plus 1 is 5 halves times 1/3. If I multiply across, I get an answer of 5 6 as my final answer. Give me an I agree if you agree if that's what you got. 5 6. Nicely done. Now, at this point, I'm going to ask the substitute to go ahead and pass out the piece of paper that you'll be cutting out here soon. Let me get rid of our work there real quick. There we go. And let's go ahead and move on to the next slide here. All right, so moving on now to the next slide. So, materials that you'll need, the substitute should be passing out, not passed out, I hope. Don't laugh at that, Braylon. I know it was funny. But you should have some triangles to cut out. Go ahead. I'm going to give you some time to cut those out, about 5 minutes or 6 minutes or so to cut those out. If you are finished early, you can go ahead and do page 248 in your math journal, okay? If you finish early and you're still waiting on some friends. There's some extra scissors that the substitute has as well, or you can borrow from a friend. You will also need a glue stick, so make sure you have some glue as well for today's lesson, all right? I'm going to pause that video now, or you pause that video now so you can have some time to cut those triangles out. All right, so now that you have them cut out, let's take a look at today's objective today. Today, we're going to be classifying triangles based off their attributes. I know attributes is a funny word, but that could be also characteristics, all right? What about its sides? What about its angles? That's how we're going to classify triangles today, and we're creating something called the hierarchies. We're going to create a hierarchy with those triangles, all right? So let's go ahead and take a look at where we've been and where we are. So our last lesson last week, we were dividing with common denominators, as you can see. And then you can see an example of hierarchy of triangles where we are today. And then where we're going is classifying quadrilaterals just like we did with triangles. All right. And there's a quick example of a hierarchy with quadrilaterals as well. Success criteria today, you need to be able to identify triangles based off their sides. So is it equilateral? All sides are equal. Scalene, no sides are equal. Or isosceles, there are two sides that are equal. And you need to identify triangles based off their angles. Is it acute angles? So that's 60 degrees or less. Obtuse angles, more than 90 degrees. Or right angles, which is exactly 90 degrees. All right, there's that success criteria today. Some of you already probably have some knowledge from fourth grade about triangles, so we're just deepening that knowledge today. So let's take a look, classifying triangles by their sides. If I were to draw a isosceles triangle, An isosceles triangle would look something like this. I know it doesn't look perfect, but as I'm putting in, these are called tick marks there. Those tick marks tell you, as the person looking at this triangle, that kind of looks like an angry triangle right now, that those sides are equal. Those two sides are equal. Now, a scalene triangle, oftentimes we see scalene triangles as obtuse triangles with that obtuse angle, so it looks like that. And we don't have any tick marks in a scalene triangle because no sides are equal. Now, equilateral triangle has it in its name, and an equilateral triangle, you will see that equilateral triangles have all sides that are equal. Notice I put two tick marks in all the way around. It could have just been one, but I wanted to show you that sometimes we might have two tick marks like this for an isosceles triangle, and then one down here that tells me that only those two are the exact same length. Now, with that said, these are classifying by sides. Now, we can also classify triangles by its angles. So one way to classify triangles by its angles is by going on to the next slide. Here it is. So a right triangle, if I had a right triangle, we're always going to see something in that right triangle, and that's going to be that little box in the corner where that right angle might be. Now for an obtuse triangle has to have a fat angle. I always call it a fat angle for an obtuse triangle. And then a cute little triangle has to have acute angles. Our equilateral triangles are always going to have all three angles are going to be acute. So they have acute angles, so also equilateral sides as well. So this is an example of three triangles based off their angles. Now let's go ahead and move on to the next slide. I want you and your partner go ahead and work together on page 247 to answer questions to number 2, A and B, and then number 3, A and B. Go ahead and work with your partner on that. And pause this video. All right, so now that you have your answers, let's check to see if you got something similar to mine. Did you put little tick marks to show that it is an isosceles triangle? Good. Now, for part B, it says draw a triangle that is not an isosceles triangle. So that would be your scalene triangle. Okay, notice I don't have any tick marks. But be careful with this because if some of my friends drew an equilateral triangle, that is an isosceles triangle as well, because for it to be an isosceles triangle, it only has to have two sides that are equal. Okay, so an equilateral triangle could be considered an isosceles triangle. So this is where it gets kind of sketchy. So please be careful there. Now, an equilateral triangle is what you should have drawn right there. And then part B, is your equilateral triangle also an isosceles triangle? Oh, well, guess what? Boys and girls, I just answered that. Yes, it is. Why? Because two sides have to be equal for it to be what? Have to be equal for it to be an isosceles triangle. So, does an equilateral triangle have two sides that are equal? Yes, it does. Okay, so it is considered an isosceles as well. Okay, didn't know that answer was coming. I was working ahead of myself, wasn't I? So let's go ahead and move on to our next slide where we're going to be using our triangles that we cut out. So now what you're going to do is watch this quick video that does a really good job about explaining triangles and hierarchies of triangle. Let's give a listen here.
Is a task-based lesson, and students will work to create a. Here are some triangles. Let's start by identifying the angle type and then look for congruent sides. The first triangle has an angle measurement of 90 degrees, or it is a right angle. This is shown by making the angle a square. The other two angles are less than 90 degrees, so they are acute. All the sides are different lengths. This can be shown by marking 1 line, 2 lines, and 3 lines along the sides. The second triangle has congruent and acute angles. These can be marked like this. All the angles are acute and all the sides are congruent. Continue marking the triangles with their angle types and whether or not the sides are congruent. One way to sort the triangles would be according to the sides. Let's use a Venn diagram to organize the groupings. The first group will be no congruent sides, or scalene. The second group will be 2 or more congruent sides, or isosceles. And the last group will be 3 congruent sides, or equilateral. The first triangle has no congruent sides. It will be placed in the first circle, so it is a scalene triangle. The next triangle has 3 congruent sides. It can be placed in the equilateral group because it has 3 congruent sides. It can also be placed in the isosceles group because 3 congruent sides is 2 or more. In order to show this, let's overlap the two groups and place the triangle in the middle. The next triangle has 2 congruent sides, and it will be placed in the isosceles group. It cannot be placed in the overlap of isosceles and equilateral because in order to be equilateral, it must have 3 congruent sides. Continue placing the triangles in the correct groups. Let's draw some conclusions about the relationships between the groups and the triangles. What do they all have in common? They are all triangles and they all have 3 sides. The overarching shape is a triangle. Let's create a tree diagram to model the relationships. The top shape would be a triangle. Notice that the scalene group does not have anything in common with the other two groups. This means that an isosceles triangle and an equilateral triangle will never be a scalene triangle, and vice versa. Scalene will be its own subgroup of a triangle. Let's take a look at the isosceles triangles and the equilateral triangles. All equilateral triangles are isosceles triangles. However, not all isosceles triangles are equilateral triangles, as shown with the portion of triangles not in the overlapping section. This means the next subcategory under triangles would be isosceles. Because all equilateral triangles are also isosceles, equilateral is a subgroup of isosceles, and they are a subgroup of triangles. Triangles are actually a subgroup of the term polygon. A polygon is any closed shape with at least 3 sides. Let's bring up the hierarchy of quadrilaterals from a previous lesson. Quadrilaterals have 4 sides and are closed, so they too are a subgroup of polygons. In fact, many other known shapes can also be added under polygons: pentagons, hexagons, and so many more. The objective for this lesson was to use reasoning to compare.
All right, now that that's over there, hopefully that gave you a better understanding of creating hierarchies, I hope, because that's what we're going to do here soon. But first, before we do that, I want you to go ahead and sort your triangles that you cut out into groups, based off sides, based off angles, and then you're going to find yourself having some triangles that don't fit your groups that you've created. So have reasoning behind it. What I would do is I would use my slate board where I can categorize my certain groups. So write down equilateral, isosceles, scalene, whatever it might be. Okay, and then triangles at the very top. Okay, so kind of create your own groups of these triangles. Go ahead and do that, and then when you're finished with that, go ahead and talk with your partner about the groups that you created. Okay. How did you divide up your triangles? Okay. And also, don't forget, all sides are equal with those tick marks. That's how you can tell that the sides are equal. Go ahead and sort your triangles that you cut out now, and then talk to your partner and answer those questions that I have off to the side with your partner. Okay, when finished section right there. Go ahead and pause this video so you can sort those triangles. So now that you have those sorted, Now we're going to create our own hierarchy of triangles, which can be found on page 246. We're going to actually use the triangle cards that we cut out to glue into our own categories that we made. For example, I have my triangle hierarchy here. Well, went on to the next slide. My apologies there. Trying things. I haven't done this in a long time. So here's my spotlight. What is this thing going to do? Okay, I'm not doing that. So triangle hierarchy. Here's mine here. So I started with triangles, and then I went down to scaling triangles. So all the triangles that don't have sides that are equal are going to go there. And then scaling right triangles is my bottom section. And then you can see here I've completed my hierarchy with my cards. So I have triangles listed at the top, and then scaling triangles. I've glued down some scaling triangles. I can see that there's no tick marks. Those are scaling. And then also I have scaling right triangles. So those are listed below as well. I glued those on. You can see there's no sides that are equal, but all my other triangles that do have sides that are equal, that aren't scaling, are coming off to the side as having their own separate category of just triangles because they don't fit under scaling or scaling/right triangles. Okay, so that's what you're going to do now as your you do. Okay, so you and your partner can work together, or you can work separately, but go ahead and check in with your partner and the substitute teacher when you are finished creating your hierarchy, okay, of triangles. Here's my example again. If you need to, go ahead and pause this video so you can see my example. But this is my example, so I challenge you to try to create your own example. Maybe you do right triangles, and then it goes on to right triangles that are isosceles, okay, and so forth. So I challenge you, create your own categories for your hierarchy of triangles. So pause this video so you can reflect and use my example to help you out. And then here's your reflection today, found on Canvas, that you can go in and click on. An equilateral hexagon is a hexagon with 6 sides that are all the same length. Here's an example of one with 15 inches all around. So here is a hierarchy. We have hexagons, equilateral hexagons, and then hexagons with one right angle. Okay? Does this shape go with the top category? How do you know? So does this shape here go with the top category? So the top category is hexagons. So would that shape go right here? Yes or no, and explain. Why did you say that with that top category? Does it go there or not? All right. So this is Mr. Fleming. I hope you guys have a great day, and I'll see you tomorrow. Have a good day, guys. Bye.